Hello, this is Ms. DB, and in this video we are going to review Chapter 1, Section 2 on properties of real numbers, and our objective is to identify and use properties of real numbers. So you already know that the four basic operations are addition, subtraction, multiplication, and division. Subtraction is addition of the opposite, and division is multiplication by the reciprocal, which might be not the way you usually think of them. But the properties of real numbers focus on addition and multiplication. So all the rest of the things we're going to be talking about do not necessarily apply to subtraction and division. You would have to maybe rewrite them as addition and multiplication before you could use these properties. All right, here we go. First of all, with the identities and the inverses. For all real numbers n, the sum of a number and 0, which is called the additive identity, is the original number. If you add 0 to a number, you get the same number back. The multiplicative identity says that if you multiply a number times 1, which is the multiplicative identity, then you will get the original number. So anything times 1 gives you the original number. For inverses, the sum of a number and its opposite, or additive inverse, is 0. So if you add a number plus its opposite, you'll get 0. Like 5 plus negative 5, you get 0. Or negative 5 plus 5, you would get 0. The multiplicative inverse is that you can multiply a non-zero number and its reciprocal, which is its multiplicative inverse, and you'll get 1. So 8 times 1 over 8 is 1, or 1 over 8 times 8 would be 1. Take the inverse and you multiply it by the original, you will get 1. All right, in Algebra 1, or maybe even before that, you learned that the opposite of any number a is negative a, and the reciprocal of any non-zero number a is 1 over a. So we have opposites are you take the opposite sign, and reciprocals is you flip the numerator and denominator. Here's some example problems to find the additive and multiplicative inverse of each number. So if you had the number 12, the opposite of 12 is negative 12, so that's the additive inverse, negative 12. The multiplicative inverse, you would have to take the reciprocal of that, which is 1 over 12, and you can check it by taking 12 times 1 over 12, and you do indeed get 1. Okay, negative 9/4. What is the additive inverse of that? It would be positive 9/4. And you can check it by adding them together and you would get 0. The multiplicative inverse is still negative. So if you start with a negative number, the multiplicative inverse is still going to be negative and you would get negative 4/9. Here's some examples from your worksheet. You have to find the additive inverse and the multiplicative inverse for each. Now you'll note that for some of them, it might be easier to write them as a fraction. So for number, or they're not number, they're 1 through 5, but for the first one, we'll call it 1. Here, I gotta get my pen tool here. 0.25 is the same as 1/4. Additive inverse is fine either way to write. The additive inverse, it would be negative 0.25, or you could write that as negative 1/4. But the multiplicative inverse, it may be easier than trying to do this. It might be easier to rewrite that using the fraction method, because that would just be 4, or 4 over 1. And the same thing with this. If this is 1, 2, 3, 4. Number 4, you might want to write this as negative 1.5, which is negative 3/2. That might make it easier to do the multiplicative inverse because you're going to take the reciprocal. There are 2 of them that your original number is negative, so your multiplicative for both of those should also be negative. All right, let's continue on with our properties of real numbers. The closure property just says that if you add or multiply any 2 real numbers, you're going to get a real number. We don't use this a ton, but I guess it's a good one. It is one of the properties. Here's some that you're more familiar with and that we'll be using more often. The commutative property says that you can add or multiply real numbers in any order without changing the result. So the commutative property means you can change the order, and it doesn't change the answer. The associative property, you don't change the order in the associative property, you change the grouping. So in this first example here, they took the 5 plus 3 parentheses and they moved it and put parentheses around the 3 plus 7. Note that to use the associative property, it has to be all addition or all multiplication. Then you can change the parentheses, change the grouping. The distributive property you should be quite familiar with. It says that the number on the outside will be multiplied by each term on the inside of the parentheses. So using algebra, AB plus AC. The number can be written at the back. It's still using the distributive property. Based on the closure property, the real numbers are said to be closed under addition and closed under multiplication. That just means if you add or multiply any real numbers, it'll still be a real number. In these ones, you're just supposed to identify the property demonstrated by each question. There's a couple of these on the worksheet. So letter A, they changed the order. So that is the commutative property. In B, they didn't change the order. It's still 3, 2, and square root of 8, but they changed the grouping, which is the associative property. Okay, here's an example where we would use the commutative property or the associative property or the distributive property or one of those other properties that we learned about. And it says to use mental math to find a 5% tax on a $42.40 purchase. So it might be easier to think about a 10% tax, because 10% of a number, you just move the decimal place and you would get 424. And then half of that would be 5%. So if we just take half of 424, we would get $2.12. So we use mental math and our properties of math. You might not have even thought about which properties you were using, but you were using them in order to solve this problem. Another thing that you're going to be doing on your worksheet is classifying a statement as sometimes true, always true, or never true. And you're also supposed to support your answer. So here's an example. A times B is equal to A, where B is equal to 3. So is there any time that you could take a number times 3 and get A back, get that same number back? Like, could you take 2 times 3 and get 2? No. How about 1 times 3 isn't equal to 1? Can you think of any time, what could A be, so that you could get A as an answer when you multiply it by 3? You think about it? I can think of one. I would say this is sometimes true. Only when A equals 0 does this work. Because 0 times 3 is 0. 0 times any number is 0. So this is sometimes true only when A is 0. Okay, here's another example. 3 times parentheses A plus 1 equals 3A plus 3. This side over here, if you use the distributive property there, you would get 3A plus 3. That's the exact same as the right side. So they're always going to be equal to each other by the distributive property. Here's some from your homework. Number 11 looks like the distributive property, but it might help you to put a 1 in front of that parentheses on the left side. So I want to see if that's equal to this. If I take A and then I do the distributive property here, I'd have A minus 1B, which is the same as minus B, minus 1 times negative C. A negative times a negative is a positive, so I would simplify the left side to be A minus B plus C. Is that what I get on the right side? If it's the exact same thing, then you would say always true because of the distributive property. If it's not true, say why. Okay, in number 12, there is a time, or maybe more than one example, where this would be true. Let's see. Or maybe this is one. Maybe I'm thinking of 13. Let's see. All right, we have A times B times 1 over A times B. This looks a lot like the multiplicative identity. I'm going to go back a few pages here, where something times its reciprocal is equal to 1. So a number times its reciprocal is always equal to 1. That is, wow, I really went back a long ways here. Here it is. N times 1 over n equals 1, as long as n does not equal 0. Well, we had AB times 1 over AB equal to 0. That doesn't seem like the way it should be. I have to quickly get to the end here. So that one, it does not look like that is not going to work because it's not supposed to be equal to 0, it's supposed to be equal to 1. And then the last one, this is the one I was thinking about. This is sometimes true. See if you could think of an example of A and B, a value for A and a value for B, when it would be true that that number over that number times 1 would be equal to 1. What would A and B have to be in order to multiply them by 1 and get 1? There is a time where that would work, or times. All right, that's it for this lesson. It's a short one. Thank you very much and have a great day.